Good morning, grade nines. Today's screencast, I want to continue our conversation about the scientific method. But first I want to do a quick recap of where we've come so far. So far in the scientific method, we know that the first thing that we ought to do, that people, the scientists or maybe non-scientists might have, is they might have a question. So you're going to ask a question about something that you observe in your surroundings, or maybe just a thought that's in your brain, and you're asking a question about it. In the scientific method, the second thing you would do is you would want to make a prediction, and the term for prediction in the world of science is a hypothesis. It's essentially, an educated guess, and it's a guess that you want to maybe do some research to be able to come up with and make one that is plausible, that is reasonable, and properly formatted. So then once you've done that, you want to be able to test your hypothesis. And that's where the fun begins, because you're going to have to do a number of different things that will allow you to experiment and maybe find the answer to your question. So by testing your hypothesis, you want to first figure out what you need, what kind of supplies you need. And in science, we call that the materials list or equipment's list. Sometimes even the equipment has a fancy name called the apparatus. You want to also figure out how you want to do the testing, and that's what we're going to talk about today the most. So that means developing what we call a procedure, and a procedure is just a series of steps that outline what it is that you're going to do or that you did. And the last thing that you want to do is you want to be able to record what happens, and you want to record what happens in an organized way and in order to represent the data in the best way possible so that other scientists all around the world can make sense of your experiment. And so that would be encapsulated in a section of a report called the observations section. So today, both the procedure and the observations are what I want to focus on in order to get us ready for our Gummy Bear Lab, which I hope to be able to do tomorrow with you, barring any other catastrophes. So in order to do that, I'm hoping that you have your Gummy Bear Lab experiment. I'm going to pull that out here. So if you can have that handy as well, I'm going to pull up the document. Oh, there's our bell. And so if you're looking at this document, you should already have our purpose and some separate hypotheses picked out. In fact, I'm going to go ahead and see if I can't find my copy of Gummy Bear Lab to see if I can find it. There we go. Right, so our question was, how might specific solutions change the length of a gummy bear? Or perhaps you adapted that so you were instead measuring the mass of the gummy bear, or the width, or the volume, various variables that we could use here. And so we decided we were going to control the volume of the solution, the temperature of the solution, maybe the color of the gummy bear, and also the time that we leave it in each of the solutions. So hopefully you have 4 hypotheses, one for the effect of each of our chosen solutions: the water, the rubbing alcohol, the vinegar, and the salt water. And some of you said, well, maybe bleach. So if you want to try a 5th solution, you can certainly add in bleach. I'm going to put a question mark there. So the next thing we need to do is we need to set up a procedure. So I think now is the time in your grade 9 science education to introduce you to a handout that I give students, and you'll have a hard copy that I'll hand out in class tomorrow. But that is the outline for a formal lab report. Now, what you're seeing right now is not a formal lab report. A formal lab report is something that you type up separately. However, informal lab reports, which is what this is, just a worksheet that we fill out, will have the same components as a formal lab report. The big difference is that this is already sort of, the template is already pre-constructed for you, and all you need to do is fill it in. But having said that, you need to know how to write up a formal lab report. And this will also help you to know how to compose a procedure and set up a proper observation table. So where do you find this report? Well, let me explain. You're going to go to my website. So I'm opening up a tab. I'm going to go to the class website. And I'm going to go to our SNC 1D tab right here. And I'm going to go to Formal Lab Outline, Grade 9 and 10. There we go. Click on that. And what you'll see here is an outline describing all of the different aspects of the formal lab report. Now, some of these details we will get into later when we actually have to write our first formal lab report. I don't want to really do that now, but you can see that it will have the same sort of general format and flow as what we've seen so far in the scientific method. So purpose or question, in this case we've decided to go with a question, but you would have either a purpose or a question. Next, your hypothesis is there, and I'm going to scroll up here so you can see materials and apparatus. Okay, so and then procedure and then observations. I'm going to zoom in here so that we're focused on the three components that we're really focusing on today, which are materials, procedure, and observations. So we've already set up our materials list. I prefer them to be in column form, but some labs may want you to, we might need to add or need to subtract materials based on the lab procedure that's given. You need to account for that and change your materials list as required. Sometimes you have like a neat or unique apparatus setup, so you might want to include a diagram just so the reader knows what the heck you're talking about. All right. So the next thing you're going to want to do is procedure. So, you know, a procedure when you're writing up a formal lab report is not written as a recipe. It's not written as a do this, do that, do this, do that. It's written as almost like a report of what was done. So in order for you to do that, you would take it in present tense and then change it into past tense. So for example, if the instruction is 100 milliliters of acid was placed in a 250 milliliter beaker, that's an instruction. It's not a report of what you did or what was done. And so what you would need to do is to change So the next section of the lab report that's important to focus on is the procedure. So the procedure, you know, unlike what you might expect, is typically not a recipe for what to do. It is a description of what was done. So for example, instead of putting, you know, it in present tense, describing what you did, you know, do this, do that, and then do this, you're not going to do that. You're not going to put we put 100 milliliters of acid in a beaker. We want to not use personal pronouns if at all possible. So instead of I and we, it would look something like this. So 100 milliliters of acid was placed in a 250 milliliter beaker. So I'm writing it without using personal pronouns and also in past tense. So I'm going to switch back to our lab here and maybe get you started. So the procedure for us, maybe the first thing we want to do is we want to make sure that we have safety gear on. And so we might want to say, you know, what an instruction might look like is this, okay? Put on safety goggles and a lab coat. But we don't want it to be an instruction. So we want it to be a report of what was done. So instead, I'm going to kind of, put that off to the side, so maybe a first thing to do would be to write that instruction, but then to convert it into a procedure report. So instead you would say safety goggles and a lab coat were put on. There we go. So now I've changed this instruction into a report of what was done, okay? And then the second thing I'm going to do is now I'm going to start laying out my plan. So, of course, our plan was, this is sort of what I was envisioning, and maybe you have a different envision. But we want to control the amounts of each solution that we put in. So maybe, you have an idea about the size of beaker that we want to use. I think we said a 50 milliliter beaker because it's pretty small. But we probably don't want to fill it up to the brim. We probably just want to fill it up to a certain amount, certain volume. So for instance, maybe I want to say, enough to cover each of the gummy bears. So maybe we can, start with a certain volume and change it if we need to, if the volume we select doesn't actually cover the gummy bear. So let's say we say, 10 milliliters of water was measured into, using a graduated cylinder, right? And then our next step is maybe a gummy bear was placed in a 50 milliliter beaker. The 10 milliliters of water was added to the beaker. And then maybe the next step describes how long you're going to leave it in, right? So maybe we're going to leave it 24 hours. So the gummy bear solution, the gummy bear / water solution was left for 24 hours. Right? And so those are some ideas. Now, you may be thinking, well, we forgot some steps. Well, what do we need to do if, in fact, we're going to be measuring the change in the length? So maybe somewhere up in here, you need to account for that, and you need to measure the length. Or you maybe, if you decided to take the mass, maybe you need to take the mass of your gummy bear. So those should be instructions that should be in there. And then, of course, we want to repeat that for each of our solutions. So maybe instead of repeating all of the steps, maybe simply somewhere down the line, maybe this is step 10 or something like that, you say steps 1 to whatever. Let's say right here I have step 4 were repeated for each of the test solutions, and then maybe you list them here. So like, rubbing alcohol, and then ... all the rest of them. Okay, so one of the tasks that I would like you to do for tomorrow, the task actually that I would like you to do for tomorrow is to write out a procedure, and then we'll kind of talk about it a little bit tomorrow together. I'll show you what my complete procedure would look like, and then you can see how yours compares so that you can learn from that, and maybe it's good to go, maybe we need to make some adjustments. And then what I'm hoping to do is we will figure out how to write out observations together and then actually conduct our experiment. So I hope that that helps to introduce you to how to write out a procedure. Again, feel free to contact me with an email in order to help you out. But come tomorrow prepared with your procedure so that we can analyze it and begin our experiment.